Hello, everyone. Welcome to another episode of AWS Show and Tell. I am your host, Anil Nadiminti, joining from New Jersey today. And joining along with me is Akarsha, right?
Hi, everyone. My name is Akarsha Sehwag. I'm a Gen AI data scientist with the AgentCore team, with the AgentCore Memory team. And I'm joining from Durham today. I'm here for a conference. And yeah, the weather is amazing. I'm loving it here. A break from New York City, where,
Right? Yeah.
where I
I was
live.
going to ask you, right? Because I know that last week you were in New York when we were
Yes.
chatting about it. But okay, great. So is this like an AI conference?
It's an AI conference. It's more focused on open source. So all of
Okay.
the open source communities here. It's great to interact with them. AWS supports all of them with full heart. So
That's
it's good to
amazing.
be here. Yeah.
That's amazing, right? So yeah, and by the way of introductions, I'm Anil Nadiminti. I'm a senior solutions architect here. I work with enterprise customers in the Web3 fintech space, more like the cryptocurrency space. So that's kind of what I support in my domain. But in today's episode, we're going to chat about AI agents, but AI agents doing things differently, right? So what we've spoken in the past is agents being able to create POCs, going from POCs to production, being able to get the power of large language models looping through the tools and able to giving them the ability to solve problems. We've also had in the past episodes where we discussed about memory observability, right? So evaluations and many other agent core suite of services. But in today's episode, we're going to talk about episodic memory, right? So maybe we're going to break this down for you between Akarsha and me, and give you an insight into what episodic memory is and how we get there. And we're going to give you some analogies of how we can compare that with our real world of how we do. Maybe, and I think I'll let
Yeah.
Akarsha give that analogy, and then about parenting, I guess, right? So how that compares with the agents. So that was a good one.
Yeah.
So we'll talk about that. Uh, just getting into agentic memory, Akarsha, like why don't we set the stage
Mhm.
for why we need more than semantic memory, and maybe let's break this down as well.
Yeah. And I think today we are also going to be focusing a lot on the patterns that we are seeing in production agents. Like in 2025, 2024, 2025, we were talking about POCs, we were talking about how to build agents. And then towards the end of 2025, when our customers matured, when enterprises started to put this into production, we were talking a lot about production-ready agents.
Mm-hmm.
And today that the industry has matured even further, when people have put their agents in production, now I think it is important to understand how production agents should work, should evolve, should learn over time, and should learn from the experiences that the real users are providing them with. And that's exactly why we are here today. We are talking about episodic memory, how we can enable our agents to learn from the user experiences, to personalize the conversations that they're having with the user, to add some more context, to add some personalization. And this is what we're going to be covering today.
And the agents have probably done in the past, right? Interacting with the users, being able to achieve an outcome, doing some reasoning. So, episodic memory will also bring that recap of that reasoning, maybe in a way,
Mhm.
right? So,
Yeah.
to be able to perform and deliver results for the next customer or
Yeah.
next interaction, I should say,
Next interaction, yes.
next interaction.
So it's talking to its future self. It's
All
like,
right.
hey,
Yeah.
next time I do this,
I
I will
better
do it
I
better.
better be smarter than the last time I did
Yes.
it before,
Yes.
right? So, excellent.
Yeah.
So
All right,
that's the
let's get into
background for
it.
that.
Hmm. All right. So, as I was talking about it, right, we've been making a lot of progress on the technical side. Like on the reasoning side, we are talking about tool use, the planning of the agents, calling different APIs, standardizing the protocols, using different kind of databases. So we are working a lot on how to make a complex multi-step workflows, or how to solve the complex problems. But once we move to production,
Mhm.
the real world hits different. So that's where the user experience, the real user queries is what counts. And then users have to feel that this agent is actually understanding what I'm trying to share with it, right? So yeah, the analogy Anil and me were talking about last time. So it's like sending our kids to school, you know?
Mhm. Mhm.
So no matter how well you've nurtured your kid, once you actually send them out to the real world, they would face it, they would experience the world very differently, right?
It's not the
So
bookish knowledge anymore, right? It's the
yes,
practical,
it's
real,
a real
relevant
world.
experience. Yeah.
And the same thing with agents. No matter how well we have tested it, no matter how many different kind of questions or queries we have tested it on, given different kind of scenarios, different kind of instructions in the system prompt,
Mhm.
when the real user talks to it, it will have more and newer experiences than it has seen in during this testing, right?
Right.
And that's where we have to improve it. And this is just one level of user experience. The second level is where we have to adapt it to every user differently, because
Correct.
we are humans. Each one of us have our own preferences, have our own ways of working, have, you know, our styles of everything we do, right? We want to have it in a certain way.
Right.
And just like us humans, you know, each time we move to a different team, each time we have a different manager, a new friend, we change the way we interact with them. And therefore, that's exactly what we expect our agents to do as well. So this, both of these things together is what consists of a good user experience, right? So let's break it down.
So no matter how much technical ability you give, I think I'm trying to understand it, right? So you need to
Yes.
still get the real world experience by, I mean, and then that interaction can be used to make the agentic, performance much better. I mean, when I say performance, not the speed, but maybe the ability to solve a problem, maybe in
The
this case,
quality of the
the
agent
quality of the,
response,
yeah,
yes, the
that's the right word.
accuracy, the efficiency, everything, right?
Mhm.
So along with personalization, also the agent itself improves the way it works. It learns from the past, and that's what guides our user experience. So let's break it down, right? Looking at the three different pillars of what a good user experience looks like. So first one is the personalization aspect, where we want to make sure that our users feel special, you know?
Mhm.
We want to give it a good customer experience or user experience. So this is where we want to learn over time the facts about the user, the preferences of the user, the role, the communication style, all of these things about the user, right, over time. So, for example, right, we can think of also in terms of personas. So let's say Alice is a user who prefers technical reports in a much detailed form. So she has an engineering background. She wants it to be very detailed. She wants
Mhm.
to have all the references and everything. Versus person number two, let's name her Carol. She's a director. She only wants executive summaries. She only wants the high level information of like what happened, did you solve it or not? That's
Correct.
it, right? It's the same incident, it's the same agent, but they want response in a completely different way. So this is where personalization really helps, right? The second pillar that I want to touch upon is the context awareness. So this is where we are making our agents aware about the previous conversations that it has had. So to make it to make it context aware of what has happened in the past. So this can include, you know, summaries of different sessions that has occurred, or facts about the user. So it could, you know, overlap with personalization to some extent.
But you need to
Um,
still get the previous conversation history back, or
yes,
else people will feel that, hey, why am I
yes,
repeating myself again, right? So you want that
yes,
the history, conversational history, to be persisting.
exactly. And also like to have a, you know, a nice follow up, you know. So hey, I remember last time we talked about you had this issue. I hope it was resolved. Okay, now is there anything else I can do for you? Or, it's a good user experience to have that feeling that, okay, they remember what I had asked previously, right?
Right.
So have that recap in some form. So this is context awareness. Now the third one, and my favorite one, the self-learning bit. So this is where we talk about learning from different episodes, different past experiences that the agent has had with the user, right? And these episodes that I'm talking about is not just going to be, some kind of a summary of the past, but more detailed analysis of what had happened, what had occurred, what was the root cause, how was it solved, what tools were used, like a very detailed analysis of, every bit of that episode. And then a more advanced level of that episode would be to generalize this information in the form of reflections. So this is where we say that, okay, based on, these episodes that have happened to me, I feel that most of the times this is what is the issue, or this is what has happened, right? Like, think about us, when we just, let's say we have just joined a new engineering role. The day one job is basically we are doing everything by the book, right? We are doing each and everything that we have learned in our universities. And then 6 months later, we're like, oh, this incident? Ah, yeah, I remember in January 4th, there was something similar that happened. So you just remember something from the past. That's what, we have, what we say as episodes, what we relate to as episodes. And then 2-3 years into the role, once you get more senior, you start observing patterns, right? You start understanding, okay, generally, this is how it works. So you start saying, okay, most of the times this is what has been the root cause. So let's start from there instead of taking it by the book and taking it step by step. So that's what experience is all about. And this is what we want also to give to our agents so that they can solve the problems, or let's say do the tasks faster and in a more efficient way.
So you're helping the agent graduate then, so is that into a more senior role, or maybe get promoted?
Yes, to promote it. They never graduate, but they
Yeah.
they get promoted. Yes, exactly.
Right. So yeah.
Graduate is a level where you're like, now you're great.
Okay.
I think this is more of a gradual learning. It's a continuous improvement. All right, so let's zoom a bit more into the self-learning bit. So what are the different components of self-learning, right? What do we want, or what do we expect out of an agent that is able to self-learn or self-evolve? So first bit is for it to remember what instances has it had before, has it seen before. So this is where we are talking about episodic memory, right? It can recall the episodes. Okay, this is what has happened in the past. These were the successful samples. This was the unsuccessful experience that I've had, and so on. The second component is the reflection part, where we generalize these experiences and we create we synthesize some patterns, some general guidelines out of it, right? That, hey, mostly this is how you solve this issue. And then the third one is we want the agent to evaluate itself based on, so next time when it is using those reflections, it has another episode, how well did it perform? Or analyzing its own episodes, analyzing its own reflections. So it's able to evaluate, what have I done? Was it correct? Was it not correct? Was this approach better than the other? The remediation that I gave, was the user happy about it? So things like this, it's able to evaluate itself.
And in this phase, do you also capture the interaction from the user, right? Because the users will give thumbs up, thumbs
Yes.
down. Be able to, capture those as well, right?
Yes. So every episode should capture that information as well. And then based on that, evaluate how the experience was and how the episode actually came into play. And then the fourth component, the most important component, is the adaptation bit, where we allow the agent to learn from all of this, from step 1, 2, 3, and based on that, adapt and improve, right? So this is where it learns how should I act differently next time? What are the guidelines to be differently in a particular situation? Because it's not super generic, right? But we can say, oh, if this kind of situation occurs, behave in this certain manner. So that's where you wanted to adapt, but for specific situations. So keep it more dynamic for different use cases, different situations that can occur.
So is it also the same as like when you're allowing the agent, are we allowing the agent to self-evaluate, or are we saying that we want to evaluate the agents?
That's a very good point. So actually, in production systems, to some extent, we do want the agents to self-evaluate because we cannot supervise each and every situation. But so just like we were taking the example of a child going off to school. So as a parent, you want them to learn by themselves, but you still want to keep an eye. You want to know what they are doing. Is it okay? So if something has a drastic failover or something drastic happens, you want to control it. So therefore, in production systems, we do recommend that aside the agent learning and improving by themselves, you should also have other measures or other metrics that are, let's say, keeping an eye on the agent to evaluate it, to observe it, to see what's happening. And based on that, perhaps in some cases, you might also need manual adaptation alongside what agent is by itself doing.
Okay, so what I think to convert that into our analogy, you're the parent is still responsible to make sure that the evaluations are looked at, right? So the report cards of the child is looked at. So maybe looking at the agentic performance more closely and understand that it's doing correctly, and then make those changes so that it can adapt better, I guess.
Exactly. So now to put that into more concrete terms, like in terms of like, how do we build it? How do we actually see this, right? So we have Bedrock AgentCore, which is our platform, which is the most advanced agentic platform for production-ready agents. So this is essentially everything that you need to put your agents into production. This is model agnostic, framework agnostic, so you can bring in any of your Strands agents, LangGraph, CrewAI, LangChain, any of the frameworks or any of the model providers you want. And to put them into production, you can use these different services to put them in production safely, securely, and scalably. Right? And in the context of what we were talking about, the self-learning agents, so memory, of course, is providing us with all of the capabilities that we need to learn from the past experiences, right? Episodic, summary, user preferences, semantic, all of those. But then just like how as a parent you should keep an eye, you have to, you can use the traces from GenAI observability to feed into the learning pipeline so that you can keep an eye. Because, famously, one of my colleagues always uses this analogy. So he says, what you cannot see, you cannot measure. And what you cannot measure, you cannot improve. And therefore, you need observability in place to be able to measure something, and you need evaluations, therefore the measurement or the metrics in place to, at the end, improve your agents. So
and that's
this
all
is
a flywheel effect. Flywheel effect.
Yes,
right? So.
yes, exactly. So that's what closes the quality feedback loop, right? That's what improves our agents. All right. Now let's focus on memory, since that's our topic for today.
And I'll also just give a brief that for folks who are watching this live stream, there is a demo that is also coming up. We're going to talk through some of the content here and then show this in a demo.
Thank you for the teaser.
Yes.
All right. So I'm going to start just to give a high-level overview of what AgentCore Memory is. So when the agent is having the interactions with the users, it creates these raw messages, right? The messages that come in from the conversation that is going to and fro between the agent and the user. So those conversations is what we capture as raw events, and we store them into a raw storage into the short-term memory. So this is essentially a data store that you just take in the messages or the checkpoints or the agent state. So anything you want to store as it is, you would store that in the raw storage in the short-term memory, right? And the short-term memory can live up to 365 days, so it's not that short-term, but it's essentially take it to be the raw storage, right? And now, based on the configuration you have created, based on what you choose of like how do you want to give a good user experience to your users, you configure some strategies for long term. So you say, let's say I want to create episodic memory strategy. So in those cases, you would pick any of one or more of those strategies, and then those, based on the strategies you've configured, those events would then flow into a memory extraction module, which is a processing pipeline. We'll go into it in a bit of what this entails, what this means. But essentially, this then creates memory records and stores them into long-term memory from where you can retrieve it, right? You can retrieve it and append it into your conversation to add more context when the user, let's say, having another conversation, to add more context from the previous episodes, from the previous chats, and so on.
So from your previous example, let's say Carol is going to Paris now, right? So would you consider that as Carol going to Paris as a long-term storage item? I mean, it could still be like, she's searching for the flights to go to Paris, right?
Yes.
So an extraction of that would be like, hey, from this interaction, I understand that Carol is going to Paris, right? So that will be an item that could be stored.
Yeah, so it depends on what you've configured. As in, if let's say I say, in my application, I do not need anything else. I only want user preferences to be stored. So in that case, Carol going to Paris is not relevant for me, right? Because it does not mean that Carol likes Paris. She's just going to Paris for some reason. But if Carol mentions, oh, I'm super excited, I really enjoy Paris last time I went there, with this, you can implicitly detect that, okay, probably Carol likes Paris. So that's going to be extracted. But not every piece of information that you send in would be extracted because it has to be relevant to that strategy, right?
Understood.
Yeah. So AgentCore Memory is providing you with a fully serverless managed service, and it's providing you with a built-in encryption in transit and in rest. It's providing you with flexible namespaces. You can scope memory differently for memory sharing, or if you want to keep it separate per agent, completely on the design you want to have. And you do not have to manage the infrastructure, so you don't have to predefine how big a vector store do I want to have. You can just keep storing memories and it'll automatically accommodate all of that. And that's really important in a production system, right? We don't want to pay for, let's say, 10 gigabytes upfront, but we want to only pay for what we use. And that's exactly what this is for.
And Akarsha, a quick question, right? So can AgentCore Memory be used independently in like outside of using maybe runtime or gateway? I know that there is a suite of services there, right? So can you clarify that?
100%. So all the AgentCore services can be used independently. Of course, they work really well together, but they can all be used independently. Same for AgentCore Memory. It provides you with the APIs, and you can use those APIs to call from any runtime or any kind of a compute wherever you're running your agent.
Excellent.
So you can run it anywhere. All right. So to go a bit deeper into the long-term memory. So short-term is fairly simple, right? We are storing all of the messages as it is. It is storing in the information, scoping it based on the user ID, the actor ID, and the session ID, and well, of course, the memory store that you store it in. For long-term memories, we have different strategies. So as we also mentioned before, so first one is the summary memory, a summary strategy. This is what creates a condensed representation of the interaction. So it summarizes the conversation, but topic-wise. So it has all of that information, all of the key points of the conversation in a summary. The second one is the user preferences, which is what stores and learns from the user behavior, the interaction style, the choices that the user takes. So the preferences and the likes and dislikes of the user, essentially, right? The semantic facts is where it literally stores the factual information coming in from the conversation. So anything about like any domain-specific information, any factual information, that's what goes into semantic. And then we have episodic, which is what allows our agents to retain and reason over their own experiences, so they can reflect back and create generalized insights or hints for themselves, for their future selves, essentially. And tying this back actually to the first slide that we were discussing, where we were talking about the good user experience, right? So we were talking about the personalization bit. So personalization is what user preferences and to some extent semantic provides us with. The second one we were talking about is the context awareness, right? That's where summaries and semantic facts would help. The third one we talked about was the self-learning, and that's where episodic memory would come into play. So all of these strategies have been created to enhance that user experience. But in case any of these do not really solve your solve the problem for your use case, you can also override the prompts. The prompts are public. You can look at them in the documentation.
They're in the chat right now. I've already added them. Yep.
Perfect. Thank you. And so you can override the prompts or the models if you want to use another ones. Or you can create a completely own pipeline of your own if you want to have a self-managed. So this is something then you can fully create a custom pipeline for your use case, right? Now let's touch upon what do we mean by this, this black box we created of the extraction pipeline. So how does it work? So the raw events that were coming in, we configured a strategy and an event, and the events that are coming in with the strategy. We wait for K messages or X seconds of inactivity, and based on that, it runs an asynchronous pipeline. So this pipeline would be running asynchronously so that the conversation is not being interrupted, right? This is going to be running in the background. So the first step that takes place is going to be the memory extraction. So that's where it extracts the relevant information. So the example that Anil, you were taking about Carol going to Paris, or let's say the Carol said, "Oh, I really enjoy going to Paris." So from short-term memory, this information will flow in here. And let's say we configured a user preferences strategy. This extraction bit will, this extraction step will extract this information that Carol really likes going to Paris. Then the consolidation bit will look at the similar memories before. Hey, has Carol talked about going to Paris before, or
is
like
it flights or is it hotels or which part of Paris? I think, right? So
that's also the context. Yes. So it looks at the vector store. What has Carol talked about Paris before? And based on that, retrieve similar information. And based on what similar information it has found in the existing vector store about Carol, it will either add a new piece of information. So it'll add a new record. If, let's say, this information did not exist, this is a new information. Or it can update. So update would be the case where, let's say, there was some contradictory information that occurred in the past. Let's say previously, 5 years ago, Carol said, I don't like Paris right now. I'm super frustrated, something like this. So there's some contradictory information. And therefore, we need to update that, right? Something changed. And so many times we keep changing our preferences. So, I mean, that's very natural, right?
Right.
Or perhaps Carol said, I like going to France, and now Carol is talking specifically about Paris. So you might want to make it more exhaustive. You want to complete that same information. So you would update in both of these cases. The third operation would be when, let's say, this information already exists. We don't need to update it. We don't need to add anything new. Then we would just skip this information because there's no point of adding redundant information.
Maybe
So
Carol is just searching for the same, the flight for maybe a better deal.
yeah,
So just
exactly.
there's no need to update anything, right?
Yes,
So just
yes. And therefore we embed an index and then put it into the vector store.
right.
So that's how it goes. So for the three strategies that we talked about, this is the pipeline for that. But for episodic, it's slightly different. Right? For episodic, it works in 3 steps. So the extraction that takes place is not just on the on one level, but on 2 levels. So first one is the turn extraction, which is for every turn, for every agent turn, it extracts that, it looks at that, it evaluates it, understands it, what happened, what was the action taken, what is the assessment, what tools were called, how did it go. So all of this information is taken into is like kind of broken down and understood, right, on the turn level. And then once the goal of the agent is completed, once the agent has actually done its task well, then the episode extraction is being triggered, and then it creates an episode out of that, of like, on a general level, how did the agent perform, right? So it's not super granular anymore. It is more on the general episode level. So think about it in this sense. Like when we have a meeting, right? We take notes on whatever important we see, right? So every time someone says something, we just note down whatever we find important. But at the end of the meeting, we then look at all of the notes and then summarize them and say, okay, this is, we then create a full summary of the entire meeting. So that's essentially the episode.
So, but in this case, do we still capture the reasoning of the agent, and then do we persist that?
Yes. So it creates multiple different attributes, which talks about, different kind of, so what was the agent tasked to do? What did it actually do? And so on. So there's different things that are coming out of it, and it also assesses itself. It also creates an assessment of itself and a reflection of its own doing, of like, how did the agent perform? And then after this, on the episode level, after this is done, it then retrieves similar episodes from the past or from the other interactions from the vector store, and then creates a reflection on a general level where it creates generalized guidelines for the agent, along with when is it relevant, right? And I would really recommend you to read the blog post that we have here, because this will give you a lot more information. We also have examples there that you can look at, and you can understand it much better. So highly recommended. All right, now let's go to the demo. All right. So what we are going to build today, or what we're going to look at today, is a web UI which is interacting with an application built using Flask. The application uses trans agents to create these agents. Those agents have been connected with AgentCore Memory using hooks. So it sends those messages into short-term memory, and asynchronously, it is being created as episodes and then further reflections. And those reflections are those episodes and those reflections are being sent to the Amazon Kinesis data stream. So this is a feature that AgentCore Memory has recently launched, that is to be able to stream this information into some other, another place that you can, use to essentially add some custom logic. So from AgentCore Memory, you would get this information
Recollection. Like maybe a recollection, right? That's coming up and says, hey, you're supposed to do this activity. Have you really completed that, right? So, I mean, we are all used to asking the agent to do something and perform an action, but and then it remembers, but maybe the agent itself could recollect and remind us.
So this, I think, this is more in terms of notifications, where you want to know if there's a new episode being created for any reason, right? You could, for example, want it to have a human in the loop. You might want to know every time a new reflection is created, I want to add this into the Kinesis data stream from which I want to look at every reflection myself. Could be a case, right? Or you might want to analyze or aggregate that data or do something more with it, right? So you could use them for anything if you want to further process this information. So we just provide this optionality to our customers that they can stream that information. And you can stream either the entire messages, whatever is being created in long-term memory, or you can just stream in the metadata. So you can just say, okay, give me the information that, okay, there's a new memory record that is being created so that I can retrieve that memory record from the AgentCore memory, right? So it could be for anything. So this example that we are going to show, in this case, we will use it to add some categorization and some aggregation logic so that we can create a dashboard on top. So we will look at that. Now, if you give me a second, I want to just refresh my credentials so that I am connected to our AWS account, and I will get my demo up and running.
So folks out there, let us know if you are actually using AgentCore Memory or memory in general, right? To be able to make your agentic interactions much more personalized, or if you are already looking at episodic memory in a different open source repository, let us know in the chat. And yeah.
All right. Can you see my IT incident response agent?
Yes.
Yes.
What is this demo going to do now?
So this is an incident response agent, which is able to receive. So as a user, I can send in, hey, this is the issues that are occurring, and it should be able to resolve that incident and then give me a report of, hey, I've solved this problem and this is what it is. So here, what we are going to look at is 3 different versions. We will look at when there's no memory, when there's episodic memory, and then when there's episodic memory plus reflections, right? So we can compare it we can compare it with and without memory. So let's start with, I don't know, let's pick any of the topics. And on the right-hand side is our memory inspector, which shows us what our memory has. So in this case, I mean, we just see the inspector with just information in store. So we have already given in some episodes. So I've hydrated the memory with really 10 different, like super different cases where, you know, it had some different IT incidents. And based on that, it created reflections. So one thing to observe here is that the reflections are more than the episodes, which is interesting, right? So it doesn't need to be 1:1 or it doesn't have to be less than the episodes or more than the episodes. It really depends on what you are sending in, because it's creating those hints for different use cases, right? And those use cases and those hints have to be very specific of like what to do in what situations. So we will look at the reflections, and I think we'll get more idea of what is happening.
I think when you see it, then you can connect better, right? So
yes, exactly. And we have like different tools in here so that the agent can use. So it essentially gives us the incident that it's been resolved. That's what's happening. This is the resolution. These are the findings. So do that.
So this IT incident response agent is doing some actions to fix some problem.
Yes.
Yeah.
So we basically gave it an issue being like, hey, API latency was spiked to 5 seconds across all endpoints. This was the error rate. It happened 30 minutes ago, right? Solve it. So it gives us the, this was the root cause. This is the resolution that I've done. And like, yeah, these are the key metrics. So now we are using episodes and reflections. So one thing, if you observed, last time the tools that was, the number of tools that were used without memory were 5. And this time it used 3 tools for the exact same question. So like the idea of self-learning is also to improve the efficiency of the agent, right? So it not just gave us a better response, but also gave it faster because it used less number of tools, right? So it does the same task, but just faster and less tools, or so less trial and error that it goes through, right? Okay, let's look at the episodes. So first of all, every episode and every reflection that comes in will give you a relevance score of how relevant is this with the current situation that is at hand, right? So based on that, you can also filter out if you want. This could also be important for some cases if you want. And within an episode, you see it gives you a detail of what happened, and then different step-wise information on, okay, what happened on every different step, and then a reflection overall for that whole episode. So it looks at its entire episode and says, okay, this is what I have figured out, and this is what the agent did. This was a better approach. This is what, this is what was the, let's say, the approach that was taken, right? So we configured it to take 2 relevant episodes and then 2 relevant reflections. Within reflections, you will notice we have the same relevance score. We have a topic. So it gives us a topic, which is, what is this reflection about, right? So this is about database connection pool exhaustion diagnostics. And this will give us some hints of what to do or how should the agent perform, and also gives us a use case of when does this apply, when is this relevant, because these hints, and I think this is what we have been doing with our system prompts. We have been giving it so many instructions, and those instructions apply to very certain use cases, like very specific situations.
Right? So because we are predefining like what could happen there.
Exactly. And then I think this is a much better way of looking at it, because our agents are doing many different kind of tasks. And we have to make sure that for every different task, just like not every user is the same, not every task is the same. So you have to handle them differently, right? For some tasks, you have to be more detail oriented. For some tasks, you have to just do them faster. So therefore, the kind of context that has to go into the model should be different, should be more tailored. And therefore, this approach of taking reflections and creating dynamic guidelines of what should this agent do in this certain use case or in this certain situation, how should it behave, how should it perform. So that's where this is. I find it very beautiful. I like,
Yeah, this is fascinating. And do we also, like, sometimes agent says, okay, now I'm going to wait for the human to give some feedback and then take the feedback and then incorporate that as part of the interaction?
Yes.
Do you think that the episodic memory would also capture those items?
Yes, definitely. I mean, one thing just to highlight is that you, within the application, you are the one who are sending those information to the short-term memory, right? So when you want to capture episodic memory, please make sure you also send in the tools and the user feedback and everything. Because if the AgentCore memory doesn't get that information, it also cannot process that information. So just to be very clear about it, that you are responsible to send that information to the short term so that it can process it. Okay, so this is one example we have seen. I also want to go to maybe one different perspective. So let's say we take this example where we talk about all HTTPS traffic is failing, customers are seeing SSL certificate. So what this did, it used 6 tools. It did the root cause analysis. It did the resolution, which says restarted the API gateway service with backup certificate deployment and forced certificate renewal. So it's now operational. Okay. Now let's do the same thing with memory. Let's see what it does. All right. So one, of course, it reduced the number of tools that it used, but also the important thing to notice is the resolution it did. It's restarted the API gateway with the ACM certificate, all good. And since DNS validation and ACM were already configured, we deployed it to ACM managed certificate to the load balancer, restoring HTTPS functionality. So it did a more exhaustive resolution. It looked at the previous things that were resolved and did a more exhaustive. So in this case, the DNS validation was also checked. But if you remember in the previous one, we were not looking at that. So it's just to make it more prominent that we are not just using less number of tools, so making it faster, more efficient, but also doing a bit more exhaustive resolution if we have the information or the patterns that have, that we have seen from the past. Yes. And then, so this is what we have been doing as, let's say I am an engineer who is doing these resolution, but then also from an admin perspective. So you remember we did the streaming bit?
Correct.
And I streamed through the Kinesis to a Lambda function, and that Lambda was writing back to this dashboard. So this is the dashboard that it was creating. And it's a very basic dashboard, but just to give an idea of what we are trying to achieve here. So I wanted to create a distribution in terms of severity of how critical is the incident that happened, right? So is it P1, P2? So I classify them into P1, P2. Then I create categories for this. Now this is all one because, as I said, I really created very different episodes, different chats, and therefore it's one each. But you can essentially create those categories and see, which categories are the issues more coming in or less there. And then you can also look at the reflections of what was learned. And as you said, as a human in the loop, you can then look at those reflections and say, okay, no, this is not what I want, or perhaps this is an important one, I want to expand it or do something. So you can directly read or write into the AgentCore memory as well. And then you can just look at all different learned insights, maybe evaluate them as you like, and then look at different situations that occurred and what was the assessment that took place. So you can, use that information that is in the memory to also perhaps categorize it, analyze it, to do more, aggregation of statistics or anything that you want to do to achieve out of it. So that's completely on you of how you want to use it. I just use it for a dashboard, so that because I wanted to classify.
So essentially, you get the real-time events from the memory on the record creation or updates or deletion, so that you can take action instead of polling, right? So I think this changes the whole dynamics of things.
Exactly.
Now, Akarsha, just to recap, going back to one of couple of things that you mentioned, right? So we had less episodes and more reflection. Can you speak about why that happened?
Okay. So as you see, right, all of the reflections are topic based. So within one conversation that we have seeded in, it was talking about a full incident and says, okay, this is what happened, and then this was the tasks that took place. So it could be the case where we were having different analysis or different how to say different use cases within the specific, because when we are having a conversation with the agent, it's not necessary that we are talking about one specific topic.
Right.
Within that whole conversation, it could extract, oh, these are the two important insights that I created. So that's kind of what happened here.
So
because
maybe
the
like in a
chats that I
travel.
gave it,
Mhm.
so chats that I gave it were like 50 messages long or so, and therefore it extracted two different. I actually haven't seen if it's two per episode or not, but essentially, it is able to
Multiple.
also look at also cross episodes, right? So different episodes it looks at, and then it understands, okay, across these 5 things, I see that this is a general pattern that I have created. So it doesn't have to be 1:2 or 1:5 or anything. It really depends on what kind of conversation is going in. In most of the cases, like where we are talking about very general conversation, where the user is sharing something like a travel agent or so, there you'll find really less reflections because the situations are not that different. Versus here, we are giving it so many different situations, right? You see, the categories are not overlapping at all. So it's able to create more reflections. So if you look at the reflections, right, let's take an example. So here, the reflection is not about DNS or anything. It's about how do I do post-incident documentation.
This is a root cause
So
analysis, right? So this is
yes,
exactly what
exactly.
when we solve problems, and we've had
Yes.
many customer interactions where we say, hey,
Mm-hmm.
we want to integrate our DevOps into like an AI pipeline and let the AI troubleshoot before the agent, before the engineer is coming on call, have the summary ready, right? So it can reflect, look at, what are all the incidents that happened in the past when there is a new issue that's created, and then keep a summary ready for the agent to be able to say, hey, now that you're logged in, this is all the troubleshooting I did. In the past, we did all these 5 things. You can now
Mm-hmm.
start and give your inputs as to how I should proceed. Is that how we could
Yes.
do? Yeah.
Yes. Yeah. Yeah. Um, yeah. So essentially, this is more like derived insights, like what it learned of like how do I do infrastructure assessment before the incident remediation. So of course, this, just taking it from one perspective, one incident happened. It did some assessment before the incident remediation. It did some documentation after the incident. So let's say in this case, it'll have these two different insights, right? But of course, it's a very abstract, very vague mapping criteria. But I'm just giving an example of how it could lead to more reflections than the episodes. But that's usually, for most of the cases, it's not that common. Like I've not seen it for 99% of the cases. It's, yeah. All right. So now we have covered a lot about the user journey and how do we improve based on the user. Maybe let's get back to the presentation.
Yeah, I want to also ask, like, maybe as we get to the next slides, right? So how do we put
Yes.
some boundaries on these interactions? Because we want some episodes, memory interactions to be like, very specific, and
Yes.
not have the agent, overlap on its memory recollection abilities. So
Yes. I mean, that's the biggest challenge in production, right? How do we make sure we have enough guardrails that the agent can function what we want it to do, but it doesn't go beyond that, like it doesn't go rogue. So that's where we want to keep those boundaries. We want to keep those guardrails. We want to have some enforcements built in. So that's one of the biggest challenges that we are seeing our enterprise customers facing. So that's where I want to talk about the scoping memory for production, right? What are the layers of scoping our memory bit when we are putting, or when we have our agent in production, or when we are putting in production? So first layer is around the short-term memory, which is for short-term memory scoping, you scope it based on the memory ID, the actor ID, and the session ID. So these are the 3 identifiers you create to put any of your messages or any of your events into the short-term memory. So the raw data store that we were talking about, right? So this way, you don't have any cross-user or cross-session bleed. So Alice cannot see what Candace was doing, or what Bob is doing, or there cannot be any mix of different users or different actors. So that's the layer 1, the fundamental one, right? Now on the layer 2, which is what is flowing in from the layer 1, by the way, just to kind of remember back. So the information that we put in the short-term memory is what is flowing into long-term memory. So on top of what scoping we did here, we are also scoping it in terms of now namespaces. Right? The namespaces is essentially a hierarchical path that we can create. We allow 3 different variables. You can add strategy ID, actor ID, and session ID, right? So those are the variables you can use to create a hierarchical path to make it as granular as you want, or to keep it super high level. That's completely the design decision that you have to take while building your agents, right? But this way you can control what information can be retrieved, or from which namespace can the information be retrieved, right? So essentially, controlling the blast radius, if you can put it that way. So yeah, what information do I have access to? So you can control that bit.
And we've discussed this in a deep dive, on AgentCore Memory. So I've linked that episode in the chat. You can take a look at that so that you can see what is that namespace, how do you control that. More in that link there.
Yes. Thank you so much. All right, and then layer 3 is then more enforcement, right? Now we're talking about hard security enforcement. So this is on the IAM level, where we want to make sure that, that our agents are given certain policy, are given certain conditions that they cannot cross. So they are given very specific boundaries that they cannot go beyond. So this is where we can use the IAM roles with the actor ID condition keys, so that only an actor can access the memory that it's assigned. And then we also have recently launched resource-based policies, which allow you to identify which resource is actually accessing this memory. So with this, you can identify which agent is able to access your memory, right? So you can combine these two to actually enforce the access on the agent, for the agent.
So this is good, right? So to break it down, we are creating how the short-term memory, the long-term memory, scoping that, creating episodes out of that. But then we're talking about how you can bring security so that you're adding those guardrails from from the code, and the actors also, like, to not be able to interact with the other memories.
Yes. All right. I think we're almost on time, right?
Yeah.
So I would want to share some resources here. Please also look at the Episodic Memory blog post. It is super detailed. We have put a lot of effort into it. It has examples also at the end in the appendix. So you can look at it, how it works, the detailed diagram. And I would highly recommend for you to try it out, see how it's working for your use case. And if you have any questions, please reach out to us. Put it in the comments. We definitely do keep an eye and respond timely.
Yeah,
yes,
excellent. Thank you for diving deep into the details of episodic memory today, Akarsha. And we'll come back to you folks with another episode on the AWS Show and Tell for next week. But until then, thank you for joining the live stream today.
Thank you.